Hi all, welcome back to Malware Analysis. I am Jay Lavanya, Assistant Professor of CSC Department. So today we are going to discuss on the topic called deadlisting. Okay, so far we have discussed about what are the sys internal tools and all the such that. So today in this video we are going to discuss on the topic called deadlisting. So let's dive into the video. So first of all, deadlisting. So deadlisting in anti-malware analysis refers to a detection techniques where the security software maintains the list of known malicious file, signature or indicator that are definitely classified as threats. Okay. When a file or an artifact matches an entry on the dead list, it's immediately flagged as malicious without requiring further analysis. So, deadlisting in the context of anti-malware analysis refers to the practice of explicitly excluding certain files, processes, or network activities from being scanned or analyzed by an anti-malware engine. So this exclusion is based on the knowledge that these items are inherently safe or irrelevant to malware detection. It's essentially the opposite of whitelisting, where the specific items are explicitly trusted. Instead, deadlisting focuses on items that are known to be uninteresting from a security perspective. Okay. So apart from that, these deadlisting in anti-malware, what means is that because there is one more thing like deadlifting is there, but this is deadlisting. Yeah, okay. So while you are studying, so make sure that you're studying properly or wisely. Okay. So deadlifting in anti-malware analysis, uh, this one such cases is that this an artifact that matches an entry in a dead list, right? So similar to that in malware analysis also, it deals with such cases like it's a ransomware that is often considered the deadliest, like historic threats like MyDoom that is occurs in the year 2004 and WannaCry in the year 2017 also demonstrate the devastating potential of malware, which causes some billions of damage affecting over 2 lakh computers globally. Okay, so ransomware as a service model further amplifies this danger by enabling less skilled criminals to deploy some destructive, attacks. And why this ransomware is often called the deadliest or the deadlisting is that because due to some financial and operational disruption, like ransomware denies access to encrypted data, forcing some victims to pay for decryption or face potentially permanent data loss. So this can cripple businesses, governments, and critical infrastructure like power grids. And rapid spread. So ransomware can spread quickly across the networks, infecting multiple devices and systems. And next, like sophistication, advanced encryption techniques makes ransomware extremely difficult to uninstall or decrypt without the key. Okay, and next, like disruption of security. So many ransomware attacks include components that disable the security application, further hindering detection and removal of efforts. Okay, so here ransomware as a service, this model allows other criminals to easily acquire and deploy some ransomware, increasingly the overall threat landscape and making it as a more pervasive danger. Okay, An example of such cases is that clock ransomware, a major threat that targets large institutions and governments using some advanced encryption to hold the data hostage and demanding payment for the decryption. And next, like Stuxnet, that occurs in the year 2010, a complex cyber weapon, likely nation state sponsored, designed to target some industrial control systems such as those used in Iran's nuclear facilities. Okay, so this is all states about the things that occurred in deadlisting, right? And next is that the deadlisting process in anti-malware analysis. So here, if you take in anti-malware analysis, here you have so many steps which is involved, right? The first step is that like you have like identify the save items or files that process known to be safe or identified. And second, like you have to focus on the potential threat, like what kind of potential you are gonna uh, save it more on potential. The system focuses on that remaining items that might be threats. Okay, and next, like exclude the safe items, that these items are excluded from further analysis. So like such cases, you can go for the dead listing processes that is involved in anti-malware analysis. Apart from that, we have so many processes or the dead listing which is involved in anti-malware. But these are the main important parts which we are gonna see here. Yeah, okay. And next we will discuss about the core components of this dead listing. Okay, the core component, the first of all is that it's hash based deduction. Second one, it's signature matching. Third, domain or URL blacklist. And last one, IP address block. Okay, so here a hash based deduction. So files are identified by some cryptographic hashes like MD5, SHA-1, SHA-256 of known malware samples. So this we have already discussed in Unit 1 and Unit 3 about the various hashing methods and deduction in order to prevent such cases, right? And second, like signature matching, so specific byte pattern or the code sequences that uniquely identify the malicious software. Okay, and then the domain or the URL blacklist. Okay, so here it involves like known malicious websites or command and control servers or phishing domain, and IP address block, network addresses associated with some malicious infrastructure. Okay, so all those such cases comes under this core component. Okay, and apart from this core component, we have uh, more core analysis which is involved in dead listing, and some of the cases are we will discuss here. So what are the various core components here is mean, like we have like hackers news, that assembly or decompilation, the process of converting the mission code of a binary back into assembly code or a higher level language like a C to understand its logic. And next, the dead listing specifically refers to this process using only some pen and paper, right? And there is one more component like metadata extraction, the collecting the information from the binary file structure. So where such as the portable executable header for the Windows binary. So this reveals the details like the creation type, compiler, and imported libraries. Okay. And next we have some Okay. And next we have some propagation or spreading, the part of the malware that enables it to spread to other devices such as through network exploits or the removable media or the email attachments. Okay, so these all comes under the core components, right? And we have like network traffic analysis, monitoring the network connection to identify the secret communication, data exfiltration attempts, or other malicious network activity. Okay, and then memory forensics, analyzing the memory dump to capture the hidden artifacts such as injected code or running processes and volatile data that may not be available on the disk. Okay, and here we have, as we have discussed, hashing link. Okay, and then we have some string analysis, like looking for some human readable strings, right, within the malware binary. So these can expose some command and control server addresses, file names, mutex names, and other indicators of compromise. Okay, so these all comes under the core components of the dead listing. Yeah. Okay. And next, we will discuss on the topic called the benefits of dead listing. Right? So, what are the benefits of dead listing? Yeah. So here they have mentioned nearly four important points of dead listing: improved performance, reduced false positive, enhanced scalability, and focus analysis. Right? And apart from that, we have like speed, accuracy, as well as resource efficiency and proven threats. Okay. Now let's see one by one. So first is that improved performance. So here, by excluding some known safe or irrelevant items or the data, the anti-malware engine can focus its resources on analyzing potential malicious files and activity. So this reduces the overall scan time and improves the system performance. And second, like reduced false positive. So what is mean by reduced false positive? So deadlisting can help to minimize the false positive by preventing the anti-malware engine from flagging legitimate files or processes as malicious. This is particularly useful for files that exhibit some characteristics similar to malware but are actually benign. Okay. And next we have like enhanced scalability. As the volume of data and the complexity of the malware increase, deadlisting becomes crucial for maintaining the scalability of anti-malware solution. By filtering out some irrelevant data, the engine can handle some larger workloads more efficiently. Yeah. And next, like focused analysis, deadlisting allows analysis to concentrate on the most critical and suspicious items, improving the efficiency of manual analysis and threat hunting. Okay, so this all comes under the benefits of deadlisting. And apart from that, we have like speed, accuracy, resource efficiency, and proven threat. Speed, like instant verification without the complex analysis. And second, like accuracy, a very low false positive rate for some well-maintained lists. Okay. And next we have some resource efficiency, minimal computation overhead compared to some heuristic analysis. And next, like proven threat, So catches known variants and establish some malware families. Okay. So these all comes under the benefits of dead listing. Okay. Yeah. And next is that what are the limitations of dead listing? Yeah. The first limitation, 0-day blindness. And next we have some evasion susceptibility. And third, like maintenance overhead. And fourth, we have polymorphic challenges. Okay. Yeah. So first, 0-day blindness cannot detect the complexity new or previously unseen threats. And evasion susceptibility, simple modifications to malware which can able to bypass some hash based detection. Okay. And next, like maintenance overhead, a list that requires some constant updates as new threats emerge. And next, like polymorphic challenges, malware that changes its signature can evade the detection. Okay. So this all comes under the limitations of the dead listing. So these are the common, common limitations of dead listing. But apart from this, we have like so many cases in case of ransomware, right? So what kind of limitations supposed to have or we could generate, yeah, in case of this dead listing, yeah. We have like opaque predicates or contraflow obfuscation or binary obfuscation. So opaque predications like conditional statement with outcomes that are known to the malware author but not obvious to some static analysis tools, right? And control for obfuscation. The malware alters its program execution path with some complex unstructured logic while preserving its original malicious functionality. Okay. And what kind of we have like polymorphic malware or stage or fileless malware or delayed activation. Okay. So these are all the cases where we could able to find the limitations of this dead listing, right? And next topic is that what are the implementation strategies in cases of dead listing in anti-malware analysis. So before going into this implementation strategies, right? Modern anti-malware solutions typically use deadlisting as one layer in a multi-tiered defense strategy, which combines it with some heuristic analysis or behavioral detection and machine learning approaches to provide some comprehensive protection against both known and unknown threat. The effectiveness of this deadlisting depends heavily on the quality, timeliness, and comprehensiveness of the thread feeds that used to populate these lists. Okay. So what are the common implementation strategies or deadlisting can be implemented like you using some various techniques like hash-based deadlisting, path, you know, that is hash-based deadlisting, path-based deadlisting, right? And process-based deadlisting, signature-based deadlisting, and behavior deadlisting, right? So these are the techniques for implementation strategies, right? So what is a hash-based deadlisting? So this involves creating a list of known save file hashes, example MD5, SHA-256, right? The file that matching these hashes are automatically excluded from scanning. So this is effective for identifying and excluding some common system files or trusted applications. And next we have like path-based deadlisting. This method excludes files or directories based on their file path. For example, temporary directories or log files that are unlikely to contain the malware can be deadlisted. And next, like process-based deadlisting, certain processes such as system process or trusted application can be excluded from monitoring, and this prevents the anti-malware engine from interfering with their normal operation. And next, like we have like signature based deadlisting. So this involves creating the signature for known safe or irrelevant files or activities. So these signatures are then used to exclude the matching items from the analysis. Okay. And next we have a behavior deadlisting. So this more advanced technique involves excluding items based on their behavior. For example, files that exhibit benign behavioral patterns can be deadlisted. So this requires more sophisticated analysis and it can be made prone to some errors. Okay. So these are some of the implementation strategies, right? And apart from this, what kind of challenges, we have discussed the limitation, but there are some challenges which offers some, it also presents some several challenges like maintaining dynamic environment, analysis technique over exclusion and complexity. Like maintaining accuracy, the effectiveness of deadlisting depends on the accuracy of the exclusion list. If a malicious file is mistakenly added to the dead list, it will be effectively invisible to the anti-malware engine, right? So dynamic environment. So in dynamic environment, where the files and processes are constantly, changing, maintaining an up-to-date dead list that can be challenging. So regular updates and validation are necessary to ensure that the dead list remains accurate. And next we have some evasion techniques. So malware authors may attempt to exploit some dead listing by disguising their malicious code as known safe files or the processes. So this requires careful monitoring and analysis to detect and prevent such evasion attempts. Okay. And next, like over exclusion, like overly aggressive deadlisting can inadvertently exclude some legitimate files or activities that are actually malicious. This can reduce the overall effectiveness of the anti-malware solution. And next, like complexity, implementing and managing some deadlisting that can be complex, especially for some large environments. So it requires careful planning, configuration, as well as monitoring. Okay. Yeah. So these are the common implementation strategies and what are the challenges could able to face it, right? And next we have like a deadlisting in modern anti-malware solutions. So deadlisting plays an increasingly important role in modern anti-malware solutions, right? It is often integrated with some security techniques such as machine learning and behavior analysis to provide a more comprehensive and effective defense against malware. And next, like integration with machine learning. So machine learning algorithms can be used to automatically identify and deadlist known safe or irrelevant items. So this can significantly reduce the manual effort required to maintain the dead list. And next, we have like dynamic deadlisting. So some anti-malware solutions use some dynamic deadlisting techniques to automatically exclude the items based on their real-time behavior. So this allows the engine to adapt to some changing environments and detect some new threats more effectively, right? And next we have like cloud-based deadlisting. So this cloud-based anti-malware solution can leverage some threat intelligence from a global network of sensors to identify and deadlist some common known safe items. So this can improve the accuracy and efficiency of the deadlisting. Okay. And next, like user-defined deadlisting. Many anti-malware solutions allow the users to define their own deadlist rules. So this provides the flexibility and allows the users to customize the anti-malware engine to their specific needs. Okay. So what are the best practices of deadlisting is that to effectively implement and manage the deadlisting, we have to consider some set of best practices that has to be followed. So first one, start the small. Begin with a small and well-defined dead list and gradually expand it as needed. And regularly review and update. So regularly review and update the dead list to ensure that it remains accurate and relevant. And next, like validate the exclusions uh, to ensure that they are not inadvertently excluding malicious files or the activities. Okay. And like monitor for evasion attempts, monitor for evasion attempts by malware authors who may try to exploit the deadlisting. We have to use a combination technique, like a combination of different deadlisting techniques to provide a more comprehensive and effective defense. And next, like document exclusion, document all exclusions and the reasons for them so that they can able to do by themselves. So automate where possible. So automate the process of creating and maintaining the dead list as much as possible. Okay. And next, like consider the impact on deduction rate. So always consider the potential impact of deadlisting on some deduction rate. Okay, so these kind of best practices we can able to follow in such cases of debt listing. Okay. So I just want to conclude that debt listing is a valuable technique, right, for improving the efficiency and accuracy of anti-malware analysis. So by excluding non-safe or irrelevant items, it allows anti-malware engines to focus their resources on analyzing the potentially malicious files or the activity. So however, it is important to implement and manage the dead listing carefully to avoid inadvertently excluding malicious code or reducing the overall effectiveness of the anti-malware solution. So by following such best practices and integrating the debt listing with other security technologies, organizations can significantly enhance their defenses against the malware, right? So in this video, we have discussed about what is meant by dead listing and what are the dead listing process involved in anti-malware analysis and what are the core components that is mainly used in dead listing and what are the advantages or what are the benefits and what are the limitations of it and what are the implementation considerations we have to take it into account, right? And dead listing in modern anti-malware solutions, so what kind of technique it is involved and what are the best practices for dead listing. Yeah. So we have sorted out so many points in this video. I hope that this video will be very useful for you. We hope we will see you in the next video. So thank you all.